Hi everybody, welcome back to another technical demo. In this demo, I'm going to showcase how to build open hybrid cloud with Red Hat technology. Let's get started. So here's the demo architecture. In this demo, I'm going to showcase a key component of Red Hat technology stack that can improve the speed, scalability, and security of hybrid cloud deployments. So developer productivity and automated deployments was improved using Quarkus, an innovative new Java framework, while the application deployment speed and consistency were increased by creating advanced GitOps workflow backed by OpenShift GitOps. In the end, advanced cluster management for Kubernetes and advanced security container for Kubernetes, which is aka ACM and AKS, and OpenShift GitOps based on Tekton and Argo City teamed up to automatically scale the production environment. There are many aspects not covered in this demo that can help customers realize the value of the Red Hat Open Hybrid Cloud vision and get better business outcome with the Red Hat. Okay, let's get right into the demo how it works. So what I want to do first is to try to create a bootstrap using CAM, which is GitOps Application Manager CLI. As you can see, I already set up a multiple parameter here. For example, GitOps repo URL, which I define my Argo City and CI/CD pipeline configuration on YAML file. And then there are actual service repo URL, which means my application, like a Quarkus application to Microsweeper. And also, I'm gonna try to use external containerized query.io to push my image. And then here's my Git host access token. This aims to push my change code into GitHub repository, which automatically trigger my CI/CD pipeline. And the last parameter is the authentication secret to access my external container registry, which is query.io. Okay, let's go to my application repository. This is Microsweeper based on Windows game, which is Minesweeper. If you have some experience back in 1995, it's so familiar in a popular game on your Windows operating system. Okay, we're going to use this application in the backend, REST API based on Quarkus application. And when I change it to Git repository, like a GitOps, this specify all configuration like Argo City and then CI/CD based on Tekton pipeline. And then when you go to setting my GitHub repository, and I already create the developer setting. I already created personal access token, which is my CAM CLI access this GitHub repository with this scope. And then in the end, whenever change the code and push the application into the Git repository with the PR pull request, it automatically trigger my Tekton pipeline. In the end, the Tekton pipeline create a new container image based on the application and push that image into this container registry. In order to do that, I'm going to setting the robot account here, container registry query.io. I already created and downloaded it on my local file system. So I just ran this command line. It automatically creates some secrets file, as you can see. So when you just looked at the secret file, you can have a bunch of the YAML file. Well, we're going to actually create this YAML file into our OpenShift cluster for integration GitOps pipeline. And also, when you try to run this multiple YAML file, you can just use OC apply. And I'm not going to because I already created that secret. And here's my, I already pulled down my GitOps and Quarkus Git repository using the Git clone. And change the directory to Microsweeper GitOps. And then just open this GitOps directory based on my ID2 VS Code. And you can see there's a bunch of YAML file to define the Argo City for a dev environment and a production environment. And this is a CI/CD actually based on Tekton to create the namespace and role binding and task and a lot of bunch of stuff define your CI/CD pipeline. As you can see, environment directory, we can have a dev and a production environment. When you go to dev and a production, for example, there are services how to define your dev environment. For example, deployment, how to deploy the application in a database, because this application actually connect to PostgreSQL database to score data. And then there are service and DB service and the route to access URL based on external URL. You can actually use customize to run this application and OC apply K. This is typo. This is OC apply K. So actually, I already done to my OpenShift cluster. So here's my OpenShift 410 cluster, and then I already installed the multiple operator to enable ACM, ACS, and then GitOps pipeline, and also Tekton, etc. You can see ACM operator already installed, and then we've got OpenShift GitOps based on Argo CD, and then OpenShift pipeline based on Tekton, and then advanced cluster security for Kubernetes ACS. Now let's change the namespace OpenShift GitOps. You can find the Argo CD CR. I already created that thing, which means we can actually have Argo CD that console. When you switch topology view, you can find the route URL and then go to Argo CD web console, which you already set it up, Argo CD application and CI/CD configuration, and the actual dev environment configuration, and here is the actual application, dev application in the Quarkus based on Microsweeper. When you click on that, you can find the old topology, how to link between application and Kubernetes resources, for example, services, and the endpoint, and then application and deployment, etc. All right, so it looks good. We all set up the development environment. So let's change it to actual dev namespace, which I already deployed based on Argo CD. Here's my Quarkus application, you can see, and then here's the PostgreSQL. I already connected from Quarkus application to PostgreSQL. So when you click on Open URL, you can find this application, the Minesweeper and the leaderboard. When you just try to play the game, just like here, and then it automatically store the data into PostgreSQL, and then you can find the actual data in the leaderboard. So let me change my directory into actual Quarkus application, what the code looks like. I'm going to open my ID2 once again, and here is a scoreboard resource like a handle RESTful API application. And I'm going to try to change some of the application on my local as a developer standpoint. Let's try to change some code in my application and then try to deploy this application change into my dev environment using GitOps integration. In the end, extend another cluster like a production cluster using ACM, and that ACM automatically deploy new application into production cluster namespace using GitOps integration. Okay, let's try to run Quarkus dev first. This is one of the beauty of the Quarkus framework, which allows me to stand up PostgreSQL automatically with a Docker container or a Podman. You don't need to set up the container for your PostgreSQL. You don't need to even try to access remote database. So as you can see, my local environment, the Minesweeper, just running just like I showed in the dev cluster, and I tried to play some of the game, just a functional sanity test. It's totally working. Here's the index.html. Let's try to change the title like my board, and also change the Minesweeper, the title with the Microsweeper. This is a Quarkus, so we're gonna say microservices, right? Even though this is a Windows programming back in 1995. Okay, let me try to reload the application, and then you can see Microsweeper, the title, and my board from leaderboard. Just change that. But one of the beauty of this Quarkus, I don't need to try to recompile, rebuild packaging, and as well as I don't try to restart my application runtime. I just save a file and then just reload the web browser, and it automatically changes everything, just like a JavaScript. Not gonna happen in the Java world in almost 2 decades, but now we can have that capability in Java application, which is really awesome. The source control navigator, I can see the 2 changes C, and I'm going to edit it. And also, I'm going to create a new branch to create a pull request. So create a new branch, let's say fix-UI, and then I just create a new, and then just edit a comment, like update the UI, and then push this branch into my GitHub repository, which automatically create a pull request. So here is my new pull request, just create and compare. And then I change my base repository with my own Git report and from my branch. And then just take a look at that, what changed in the comparison, my board and Microsweeper. Looks good. And I just create a pull request from my Git repository. This is a normal practice, how developer actually change the code. And the next step to create a PR before they deploy the application into dev cluster or Quake cluster. When you go back to OpenShift and the CI/CD namespace, and you can see the Tekton pipeline automatically started based on pull request. When you click on the detailed status, and then you can find the build imaging just started. It takes some time. So in the meantime, let's try to merge this pull request because we have already compared what change already done there, and it will take some time to finish build imaging. In the end, once we complete the build imaging, it automatically containerize the application with the container and then push it into our Kuwait.io because we already set it up the authentication to Kuwait.io to push the image automatically from the GitOps pipeline. Okay, just done. And then here is i3 image tag in the current situation. And then I just reload, and then you can find the new image tag here, which is just pushing into my Kuwait.io by Tekton pipeline. So now I'm going to replace the image tag with the raised container image, just push it into Kuwait container registry. I just change that, and it will detect by Argo City automatically. So go back to Argo City web console, and it will see your dev microservice application automatically processing. In the end, it will be synced from your Git repository, and then go back to WebMI in dev cluster. I'm going to reload the application. Now you can see the microsweeper and my board, just like I changed my local machine. It just happening. I just create a PR, just like a practice for developer standpoint, and it automatically detect the application code change from Git repository, and then containerize the application and then push it into my external container registry, and then I just retag the container registry image into my GitOps repository, and it automatically detected by Argo City to deploy the application into that cluster, which is really cool. So what I'm going to do next is I'm going to open my ACM, the Advanced Cloud Management for Kubernetes. When you go to cluster menu, I have one cluster, local cluster, and then here's the cluster set, which allows me to add more cluster from hybrid cloud or even on-prem to extend my cluster. And then in the end, I'm going to manage the multiple cluster in single panel console, which is ACM console. So when you click on create cluster set, you can set it a name and a bunch of the cluster. But one of the beauty of the ACM, what I'm gonna do today is I try to use cluster pools. So you can actually create a cluster pool in advance, and then just like I already created 2 clusters, which are already hibernated, which means when I create a new cluster using cluster pool, it automatically unhibernate existing pool, which make me reduce time to stand up new cluster for production or staging, whatever I need. So this is one of the cool features. I already created a new cluster pool in Amazon AWS. You can also set it up public cloud, for example, Azure Cloud, Google Cloud, DigitalOcean, etc. So I'm going to go to application. When I publish a new cluster, and then I'm going to deploy the application itself. In order to do that, the ACM enable developer or SRE and DevOps engineer to create the application set in advance. So in the application set, automatically pick that up and deploy the application into new cluster once ACM completes to publish a new cluster. So when you go to application set, I'm just creating a new Argo City application set. So first of all, I'm going to add a new application for environment for production. So I'm going to try to use the GitHub server. Here's my GitHub repository. I'm going to report to all application setting and environment setting from the GitHub repository with a bunch of the YAML file. And then to set it up, first of all, environment, like a production environment. And then I'm going to read the override the security. Here's a really important thing. You have to use the existing premise set. I already showed the product cluster, which is a target environment. Just create a new one, and I'm going to create another one, actual application Argo City set. So the name is product application-app. I'm going to use the same repository, and here's the new path, the actual application microservice Quarkus. So there are 2 applications set in a summary. One is environment, the other one is actual application with the same target product cluster placement. So you cannot see the application set right away because we actually don't deploy the application at this moment because we don't have any cluster provisioning at this moment. So once you provision new cluster and application set tied up with the new cluster, in the end you can find a new application here like a product-app, something like that. All right. So now go back to cluster and then try to claim the cluster pool. Click on cluster claim and then let's say product cluster claim. It takes some time to create a new one. And you can also find the view logs, how the cluster is provisioning, as you can see here. And then when you go back to application, and click on dev application, we already provisioning and deploy application. There is a similar view like a topology view in OpenShift cluster. And then when you click on the application, and here is the topology view, you can find the relationship in the cluster for multiple Kubernetes resources. When you click on route, for example, and you can find the launch URL, and then you can see the same Microsweeper application when you deploy with the new code into dev cluster. Just go back to existing one, you can same thing. And then here is the Argo City. In the end, you're gonna find a new production deployment in Argo City. Okay, it takes some time. So, in the meantime, let's try to go to ACS, the Advanced Container Security for Kubernetes. So when you click on ACS operator, I already installed operator as I showed earlier. And then here is ACS start rocks, the namespace. I already created central service, which allows me have ACS Web Console. Click on the ACS Web Console, and then you can see there's no violation because I didn't add a secure cluster at this moment. Let's try to add a new cluster. So one of the good things is the ACS console, which can be edited as the security cluster. So in order to, I'm going to set it as some security and secret to access the cluster for scanning or violation. So one of the good things is ACS provide a Helm chart integration setting up cluster. When you go to select on Helm chart and generate the bundle, which generate a bundle of secret to access by ACS to scan all violation. I'm going to download the YAML file and I'm going to try to create using OC command line the bunch of secret here under the downloaded directory and into ACS start rocks namespace. So once I created 3 secrets on the same namespace, I'm going to copy this endpoint or central services and go back to OpenShift cluster and then just try to create a secure cluster. And then I'm going to leave the all set it up by default, but central endpoint actual the ACS cluster services. Okay, so go to pod. You can find a bunch of the application pod will be starting to create a secure cluster. Okay, it's all deployed, and go back to ACS and dashboard. You can find the one minimum based on edit a new cluster for security. And now I'm gonna go to compliance to try to scan environment once again, and then you can find a lot of compliance issue, but not a critical. It's just a minimum stuff. So when you reload that thing, and then you can find maybe a high, minimum, low, it takes some time to aggregate all data from the existing cluster. For the compliance, you can see there are cybersecurity for Docker benchmark and for Kubernetes. And also there are a lot of perspective of the violation and security issue you can detect in scanning by ACS, which is really cool to keep securing your cluster. Okay, so let me try to one good example of some kind of Log4j CVE violation, which is really popular a couple months ago. So here's my Java application, which already exposed the Log4j shell CVE issue. I'm going to use this deployment YAML file and just copy the YAML and go back to OpenShift cluster. And I already created an empty project, the CVE test namespace. I'm going to paste in import URL YAML editor. And then this is the Spring Boot application. So I just deploy new application, go to pod, and then click on the actual runtime logs file, and you can see the Spring 261 version, and this is actually edited Log4j shell. So now I'm going to go back to ACS and then just scanning my security cluster once again. And let's take a look at that, how the compliance data changed. So go back to dashboard, you can find a bunch of the change, a lot of compliance issue. So when you click on critical issue, it showed Log4j remote code vulnerability. And then when you click on the detail, you can find the violation and which deployment impacted here. A bunch of the management you have to figure it out. When you go to network graph, this is one of the great feature on ACS. You can find the dependency and relationship across the application and topology. So if you find or detect find the vulnerable issue, one of the application, you can find which application could be impact from that vulnerability. This is a really awesome feature. Let's go to ACM to check it out, how cluster provisioning is going on. Okay, so production cluster just completed. And then when you click on detail, you can actually go to access URL console. And then when you go back to ACM, you can find the IDM password queued admin by default. And you can set it up all cluster admin or normal user in the end. So this is a new cluster. And then back to the Argo City, you can find the two production environment and application itself. Oh, we can find the auto sync. So let's try to set it up auto sync, what happening in there. Click on the application, and then this is auto sync because the default image on the production is a little bit old, but as you know, we changed the application to my board, so that's why the Argo City detects some kind of difference, like a showcase auto sync. So I'm gonna change the race code. So I'm gonna force to synchronize it automatically syncing from Git repository. And then now you can see the PostgreSQL and then Argo City in the application is automatically changed that. Okay, so it's the same thing. So let's try to sync again manually. So this is a really good feature to SRE and DevOps engineer. What kind of change is happening in the dev cluster, which is a different snapshot between dev and production cluster. In the end, they decide, okay, I'm gonna synchronize this application from Git repository, and it looks good. And then go back to the ACM in the application menu. You can find just once again open my dev cluster based on MicroSweeper and my board. You can see that. And then I'm going to change it to production application, and you can same topology and then open cloud URL, the endpoint. You can see the MicroSweeper. So let's just try to zoom in a little bit URL. This is a product and this is a dev for the same application because we just published a new product cluster in Amazon with OpenShift port 10, and then it automatically deploy new application with the exactly same code in dev cluster into production cluster. Try to play the game, just a quick functional test. It's totally working. And then back to the Argo City, as you can see, you have now dev cluster and a production cluster. If you wanted to claim another cluster from Hibernating Connect Cluster Pool, you're going to create another production cluster. It will show up in Argo City as well in the end. Just a quick summary. In this demo, I'm going to showcase the key component of the Red Hat technology stack, which can improve the speed, scalability, and security to build your own open hybrid cloud. With multiple Red Hat technology, such as OpenShift Cluster and ACM, ACS, and GitOps pipeline, with just not separately, it's to integrate all kind of bunch of stack to build your open hybrid cloud for more advanced GitOps pipeline and DevOps pipeline for hybrid and multi-cloud strategy. Thanks for watching. Have a good rest of the day.